would be where you decide you either if we assign material to it, then it will cut it. If we select skip, then it will respect it in our rendering so that we know that it exists in the assembly, but it won't be able to process it for laser or press brake or anything like that.
Okay.
So we'll skip that one. This one here, this is a bolt. Are we good to continue, or you got the recording going?
Yeah, I got Teams recording for us here.
Okay, so we're skip. Now these parts here are all 3/8, so
Yeah.
I can choose all the 3/8 parts together and assign the material to them. So now it's know that it's hot rolled.
Sure. Yeah.
And
I think for
this
us it
half inch,
technically be stainless steel, but I get the idea that that's you assign whatever you want to it. Yeah.
yeah. Now this part looks like it's a machined component. I don't believe that this one was supposed to be processed, just from my best guess.
Sure. I am curious because it is generally machined, but maybe let's say we wanted to cut out the blank and then have that blank machined. So it is a different thickness and it recognizes that.
Yeah, so it's going to measure it at its thickest point.
Uh-huh.
So it's, for the sake of the demo, do you want this part processed, or would you not process it?
Yeah, let's process it for the sake of the demo.
Okay. And this is a nut, so we're not going to process that, and then we won't process the tube. So now it's got all the parts that it's going to process identified here.
Mm-hmm.
The only other one I was wondering about, is there? Nope, that's it. Okay. So we'll go ahead and get started here.
Okay.
So now it's going to go through and separate each of these parts out, and the components that like nuts and bolts and things like that is going to disregard, and then is what it's going to do is apply the material properties to these components and turn them into SEM models. So when it converts it into an SEM model, now it's embedded with all the information needed to manufacture it on the different pieces of Amada machinery. So for example, it sees those countersinks and it's going to say, hey, we either have to just cut the through hole, or we need a combination turret laser combo machine, and then we'll cut the through hole with the laser, and then we'll use a countersink tool to create the countersink. Since we don't have a combo machine or a turret, it's only going to process the through hole.
Mm-hmm.
If there were any parts that had bending on it, it would go and it would look at our library of press brake tooling, even if it's non-Amada machinery, like if you have AccuPresses with Wheela tooling or anything like that, it'll go and it'll look at our Wheela tooling and measure the punch tip radius and the die shoulder radius, and then it will apply the bend deductions and it'll generate the flat patterns. And then even if we're not going to be making it on a Amada press brake, we can still get flat patterns that we'd be able to utilize that would be correct for whichever press brake we are bending it on. So we'll get the report, which will show us each of the parts that it was able to identify. Then it'll show which parts it converted to an SEM. So you see that list is shorter because it skipped over, the not used parts.
Sure.
And then at that point, it applies the method of manufacturing. So this would be where it finds those countersinks. And then we can see this is the flat patterns that it generates. So it just has, I think it was 357 or something like that, through holes.
Sure.
And then it will, create DXF files if you need those for like a FabriVision inspection scanner or something of that nature. And it'll export each part out into the estimation works and tell you how much it's going to cost to make it. And then it saves that assembly into the database.